There are mysteries in the universe that make us feel small, fragile, and deeply curious. Black holes are one of them, places where time slows down, light disappears, and reality itself bends. Today, we'll try to answer the most fascinating questions about these invisible giants, and maybe understand a little more about our place in the cosmos. Let's start! Is a black hole a hole in space? No. A black hole is a spherical region from which once you enter, you can no longer exit. The surface of this sphere is called the event horizon, and if you look at it from the outside, it is completely black because not even the light can come out of it. But if you turn around this spherical surface, you always see the same thing from any position, that is, a completely black disk. Just as if you turn around the sun, you always see a luminous disk. How big is a black hole? The horizon radius of a black hole is called Schwarzschild radius and depends on the mass produced by the black hole. A black hole 10 times larger than the sun would have a radius of just 30 kilometers, while a black hole of 1,000,000 solar masses, like those found in the nucleus of galaxies, has a radius of about 3 million kilometers. In theory, there is no limit mass for a black hole. What matters is simply that a certain mass is concentrated all within its Schwarzschild radius. Will the sun become a black hole? No. A star can collapse and become a black hole when the nuclear reactions that keep it in balance are extinguished, but only if it is massive enough to become incredibly dense during the collapse. And this happens only for the stars that have a mass many times greater than that of the sun, so the sun will not become a black hole. Do black holes suck things up? Absolutely not. A black hole is not a vacuum cleaner. In fact, the gravity around a black hole, if you are far enough, is identical to that of an object of the same mass that is not a black hole. For example, a star. So if, for some strange reason, the sun instantly turned into a black hole, which will not happen, rest assured, the planets would continue to orbit exactly as before. The problems only arise when we go beyond the horizon of a black hole. So what happens when we get closer to the horizon? It depends. Let's say you don't trust yourself, and before you get close to the horizon in person, you throw a clock in that direction. As the clock approaches the horizon, you will see it ticking slower and slower, and moving more and more slowly. This is a consequence of Einstein's general relativity, which tells us that time flows more slowly in proximity to a mass, where the gravitational field is more intense. So you will see the clock slow down more and more, and in reality, you will never see it go beyond the horizon, even waiting forever. But this is not the only thing that would happen. The wavelength of the light that starts from the clock towards you would be stretched, because it would undergo the phenomenon of moving towards red, the gravitational redshift, so it would get bigger and bigger, and you would see the clock fade away until it becomes invisible. In short, this is the real reason why a black hole appears black from the outside. In fact, this is also what you would see if you could observe the collapse of a star that is becoming a black hole. You would see it getting smaller and denser and darker, but you would never see the surface of the star cross the horizon. And in fact, the first name that was suggested for black holes was frozen star, or frozen star, which would have been perhaps a more correct name, but it would have been less successful. Okay, but what would happen if you were to get close to the horizon of a black hole? Well, from your point of view, nothing special would happen at the beginning. It would be like getting close to an object of the same mass. As long as you are out of the horizon, you could also reverse the rotation and go back, but you would have to spend a lot of energy. And if a friend of yours had stayed to wait for you at the point where you left, going back you would find him aged. Because for you, who got close to the mass of the black hole, due to the dilation of the times of general relativity, the time would have passed more slowly than for your friend. And what would happen if you crossed the horizon? Well, if you were so unconscious to cross the horizon, you wouldn't notice anything special there and there, if the black hole was big enough. The horizon is not a border. There is not an edge that warns you that you are crossing the point of no return. But once inside, you could no longer go back, not even spending an infinite energy. In reality, the horizon would move away from you at the speed of light. Or, said in another way, you could not stay still in space, but you would be forced to rush towards the center of the black hole. In reality, a bizarre thing that happens inside the horizon is that the spatial and temporal coordinates exchange. Outside the black hole, you can stay still in space, but you are forced to move in time towards the future. But inside the black hole, the opposite happens. You cannot stay still in space, and you have to move towards the center. You can't avoid it. Just like outside the black hole, you can't avoid arriving tomorrow. So, would you have no escape? No, I'm sorry. In a finite time, you would rush at very high speed towards the center of the black hole. But even before that, you would be torn to pieces by gravity, which would stretch you, making you become a kind of very thin spaghetti made of atoms. In reality, for smaller black holes, this spaghettification would happen even before crossing the horizon. Instead, in the case of larger black holes, like those found in the nucleus of galaxies, you could cross the horizon in columns, but after a while you would still have a bad end. But before rushing to the center of the black hole, would I see the whole history of the universe pass? Actually, no, because for you, time continues to pass normally, and looking outside, you would actually receive only a finite amount of information before crossing the horizon. And once inside, everything you would see coming in from outside would be completely messy. You wouldn't be able to reconstruct anything for the events that happened outside. And what would I find in the center of a black hole? Actually, we don't know. According to general relativity, if the collapse was unstoppable, a singularity should occur. That is, an infinite point of density in which there is no more space or time. But in reality, general relativity alone is not enough to understand what would happen in the center of a black hole, and we still don't know the right physics to describe what we could find in there. So, for now, we can't answer. The only way would be to go in person to see inside a black hole, but then we wouldn't be able to go back and tell anyone. But this is just one of the many things we still don't know about black holes, and we'll talk about it another time. That's all for today. If you want to stay truly updated and not miss what's coming next, make sure to subscribe. See you soon in the next video. Don't miss it.